Passing the ACI Shotcrete Inspector exam requires more than recognizing good concrete. Success depends on the strict application of numerical limits and procedural standards that define every stage of the shotcrete process. We will organize the 15 highest yield exam rules into 4 distinct memory buckets: placement specs, weather limits, testing standards, and acceptance math. Approaching the material through these buckets prevents cognitive overload. It allows you to build a structured mental scaffold that can be recalled during the high-pressure environment of exam day. Our first bucket covers the physical setup. Rule 1 keeps the nozzle distance between 2 and 6 feet from the wall. Rule 2 applies to dry mix systems. The water pressure must be maintained at least 15 psi above the air pressure at the nozzle. For wet mix, Rule 3 limits the slump to between 2 and 4 inches. Rule 4 defines the curing requirements. The material must be cured for 7 consecutive days or until it reaches 70. Rule 8 requires that regardless of how cold the air is, the shotcrete material must be kept at 50 degrees or higher at the time of placement. Consider this scenario. The air is 92 degrees, the shotcrete mix is 94 degrees, and the steel rebar is 91 degrees. Based on the rules, decide if placement is authorized. Placement is rejected. While the air and mix are within limits, the 91-degree rebar exceeds the surface limit set by Rule 6. Bucket 3 covers physical testing. Rule 9 defines the standard test panel size. It must have a face of at least 16 by 16 inches and a minimum depth of 5 inches. For nominal production testing, Rule 10 specifies that the cores extracted from these panels must be 3 inches in diameter. Rule 11 establishes the testing frequency. A new test panel is required for every 50 cubic yards of material, or for every combination of mixture, nozzlemen, and workday, whichever produces the higher number of panels. Dist frequency ensures that if any variable in the process changes, whether it is the person at the nozzle or the time of day, the quality of the work is immediately verified against the project standards. Rule 12 establishes 2 criteria for compressive strength acceptance. The average of 3 cores must meet 85% of the specified strength, and no single core can fall below 75%. Rule 13 uses a visual grading system for cores. A core is rated very good if the total void area is 25% or less, or if the bonded encapsulation of reinforcement exceeds 90%. Rule 14 follows a predictable mathematical progression. For each grade drop from very good to satisfactory, the allowable void area increases by 5%, while the required encapsulation decreases by 10%. Rule 15 distinguishes the governing ASTM standards. ASTM C1140 covers the preparation of the test panel, while ASTM C1604 governs the testing of the core. Acceptance requires passing both the strength data and the visual criteria. A high compressive strength result does not override the presence of a visual void or poor encapsulation. An inspector's impact is most significant during the placement itself. The primary objective is to ensure that no visible defect is allowed to become a hidden defect. You must watch the material encapsulate the reinforcement in real time. If a nozzle angle is too steep, it creates a shadow void behind the bark. Without immediate correction, the next pass of material will bury that void, making it invisible from the surface. These 15 rules represent the high-yield core of the exam. You may want to pause the video here and take a screenshot of this summary to use during your final study sessions. Passing the ACI exam is about moving past visual assumptions. By strictly enforcing these exact numerical limits, you ensure the structural integrity of the shotcrete placement.